Here's a couple of examples of solving exponential equations using logarithms. So for example, we might have 4 to the 2x plus 3 equals 10. This is not something where we have a commonality, an obvious commonality between 4 and 10. They're not both nice powers, simple powers of some other base. And so we've got to really use logarithms. And at some point, the calculator is going to be involved. But what can we do? Well, there's two strategies. So first method would be to try to use the log base to the base 4, which makes a lot of sense because 4 is the base here. And so we use the fundamental principle that to say that y equals log base 4 of x is equivalent to, let's just say, it means that 4 to the y, I already jumped to e because e is such a great base. It means that 4 to the y equals x. The log base 4 of x means the mystery exponent I have to raise 4 to in order to get x. So how can we use that principle in order to solve this? Well, we've got an exponential equation, 4 to something we'd like to figure out equals 10. Oh, here's 4 to some mystery equals a known quantity. That translates into something that reveals the mystery. And so that exponent is equal to log base 4 of 10. So whatever this thing is in the exponent, it doesn't matter yet that it's something complicated and not just a single letter. It's the way I like to say it is, it's in the inner layers of the onion. We're just stripping off that outer layer of the onion, the 4 to the something part, and the way you strip that off is with a log. And then 2x equals log base 4 of 10 minus 3, and so x equals log base 4 of 10 minus 3. Whoa, that didn't work. Minus 3, and let's just put it 1/2 in front. Okay. Now, the calculate, depending on which version of the operating system of the TI you have, you can use the log base command to do this directly, or you might have to do something clever with like a change of base formula. Well, that's related to the other way of solving this. Although, first, one variation on how you would get from the original equation to this. One way of saying this, let me just put in an extra line here. I think the best way to do it is to really understand this idea that you can move an exponential over and it becomes a log automatically. But some people do it in one extra step. They take the log base 4 of both sides. Because you can always do the same operation to both sides, and then you have the log base 4 and 4 to the, those two functions right next to each other, and then you use one of the principles that basically embodies this fundamental principle, that the log base 4 of 4 to the something, those cancel out and you get 2x plus 3. Some people like that better. In fact, probably if you asked like most working scientists or engineers, they'd probably think of it this way, that you're taking the log base 4 of both sides. Okay, so what's another way to do it? Especially if you don't think your calculator is set up for log 4 directly. Well, you don't actually have to use a base. That's the wonderful thing. You don't actually have to use a logarithm that's adapted to the base if you know enough about rules of logs. What I'm going to do is, it's analogous to this way of doing the first method. I'm just going to take either the log base 10 or the ln of both sides. Now here, it's kind of tempting to take the log base 10. As a mathematician, I'm tempted to take the log base e, but let me just go ahead and take the log. And so log without any subscript is going to mean log base 10. And that has the advantage of this being just 1. The common log, rather, of 10 is just 1. Okay. And now I have to remember what happens with the log of a power. That's one of the rules of logarithms. 2x plus 3 is going to 2x plus 3, sorry, times the log of 4 is going to be equal to 1. And so 2x plus 3 is now equal to 1 over the common log of 4. Oh, that's weird. First we had it as a log base 4 of 10, on sort of on the top of a numerator of a fraction, if you like, with denominator 1, and now it's the denominator of a fraction with numerator 1, and it's log, let me just emphasize, that's log base 10 of 4. Is that true, that log base 4 of 10 is 1 over log base 10 of 4? It sure is. It's an example of the change of base formula. If I just write the top in a rather silly way as log base 10 of 10, which after all is where it came from, that was really log base 10 of 10, that 1, then that's the change of base formula. That if I take the log with respect to these two bases, log 10 of 10 over log 10 of 4, it gives me the log of the top with respect to the base 4, log 4 of 10. So the change of base formula confirms that that's exactly what I had to start with. And then the rest of the solution is exactly the same. You just get x equals 1/2 of this funky thing, log 4 minus 3. Okay, good place to stop.